Imagine you're aboard a spacecraft approaching Saturn. From a distance, it looks almost peaceful. Soft golden bands, those impossibly thin, glittering rings. It's beautiful, but as you get closer, something feels wrong. The radio crackles with static you can't explain. Your instruments register lightning 1,000 times more powerful than anything on Earth. And then you realize you're not approaching a peaceful, ringed world. You're approaching something that has been quietly devouring itself for millions of years. Saturn isn't the gentle, elegant planet of postcards and screensavers. It's a slow-motion catastrophe, wearing the most beautiful disguise in the solar system. Let's start with what Saturn actually is, because most people don't grasp the scale. Saturn is the second largest planet in the solar system. You could fit over 760 Earths inside its volume. But here's what makes it truly strange. Saturn is so light for its size that if you found an ocean large enough to hold it, the entire planet would float. It is less dense than water. That airy, almost weightless giant doesn't sound dangerous. It is not gentle at all. Now zoom in on those rings, because what looks like delicate jewelry is actually a crime scene. The rings are billions of chunks of water ice, spread across a disk over 280,000 kilometers wide, yet barely a few hundred meters thick. Here's the part that should unsettle you. The rings are dying. NASA's Cassini spacecraft measured ring rain, a steady fall of ice and dust pulled out of the rings by Saturn's gravity and burned up in its atmosphere. Roughly 10,000 kilograms of ring material falls into Saturn every single second. At that rate, the rings have somewhere between 100 million and 300 million years left before they vanish completely. In cosmic terms, that's nothing. Saturn has existed for 4.5 billion years, and for most of that time, it likely had no rings at all. What we are looking at is a temporary decoration, and we are watching it disappear in real time. But the rings aren't the scariest part. The deeper you go into Saturn, the worse it gets. Saturn has no surface. There is no ground to land on. The atmosphere simply thickens with every kilometer you descend. At a certain depth, the pressure crushes hydrogen gas into liquid metal. Liquid metallic hydrogen churns in an ocean wrapping around Saturn's core, and that ocean generates Saturn's magnetic field. Saturn's magnetosphere stretches over 1 million kilometers into space, trapping charged particles from the Sun and accelerating them to dangerous speeds. When Cassini flew through the gap between the planet and its innermost ring, engineers expected debris. Instead, the gap was eerily empty, swept clean by forces still not fully explained. Saturn's upper atmosphere also extended far higher than predicted, creating drag no model had accounted for. On September 15, 2017, NASA deliberately flew Cassini into Saturn's atmosphere to destroy it, refusing to risk a crash into a moon that might harbor life. Cassini hit the top of the atmosphere at over 110,000 kilometers per hour. Its thrusters fired at full power for 91 seconds, fighting to keep its antenna pointed at Earth as the atmosphere tore it apart. Then the signal went silent forever. Saturn doesn't just look violent, it behaves violently, on a scale that defies comprehension. At its north pole sits a permanent storm shaped like a hexagon, with sides longer than the diameter of Earth, unchanged since Voyager first photographed it in the 1980s. Wind speeds inside that hexagon reach 322 kilometers per hour, equivalent to an EF5 tornado, except this tornado is the size of 2 Earths stacked together. It has been spinning continuously for at least 4 decades that we've directly observed. Saturn's lightning is even more extreme. A single bolt can release 10,000 times more energy than lightning on Earth. Cassini tracked one storm that began as a small bright spot in December 2010 and grew until it wrapped entirely around the planet, raging for nearly 200 days before consuming itself. A thunderstorm on Saturn isn't an event. It's an era. You might think at least Saturn's moons are safe, places we could one day study without fear. But even here, Saturn doesn't let go easily. Enceladus, a small icy moon barely 500 kilometers across, has geysers erupting from its south pole at speeds faster than sound, venting an entire subsurface ocean into space. Cassini flew directly through those plumes and detected water, salt, organic molecules, and silica particles, evidence of hydrothermal activity at the ocean floor. It is one of the most promising places in the solar system to search for life, and it exists only because Saturn's gravity squeezes and flexes Enceladus on every orbit, generating the heat that keeps that ocean liquid in the first place. Titan, Saturn's largest moon, has lakes and rivers, but not of water. They are liquid methane and ethane, at temperatures over 290 degrees below 0 Fahrenheit. The Huygens probe landed there in 2005 and photographed a landscape that looked eerily like Earth, carved entirely by chemistry no human has ever touched. Even Iapetus, discovered over 300 years ago, carries scars that took 3 centuries to explain. One hemisphere is blindingly bright, the other nearly black, and a mountain ridge over 300 kilometers long runs along its equator, with peaks twice the height of Mount Everest. Nobody fully knows why it's there. Let's pause here, because I want you to understand the full picture. Saturn isn't dangerous in just one way. The rings are dissolving. The magnetic field is almost perfectly aligned with zero tilt, something no planetary dynamo model fully explains. The storms are permanent. The lightning is catastrophic. The moons are either geologically tortured or chemically alien. There is no gentle version of this planet hiding underneath the postcard image. And here's the part people overlook. Saturn is still actively losing pieces of itself right now, while you watch this. Every second that passes, another 10,000 kilograms of ring material falls into the planet that made it. So why do we keep sending spacecraft there? Because the same violence that makes Saturn dangerous makes it scientifically priceless. That liquid metallic hydrogen interior teaches us how gas giants form throughout the universe. The ring rain phenomenon is rewriting our understanding of how planetary rings are born and how they die. Enceladus and Titan represent 2 of the most promising environments for life beyond Earth ever found, both existing specifically because of Saturn's gravitational cruelty. Cassini spent 13 years in orbit, and sent back data scientists are still untangling today, years after the mission ended in deliberate destruction. Every close pass through the rings was a gamble against debris, radiation, and a planet that does not forgive mistakes. We will never walk on Saturn. There's no surface to walk on. We will never build anything in its atmosphere. Even our most advanced spacecraft can only study it for a limited window before the environment threatens to destroy them. Here's the sobering reality. Saturn has existed for 4.5 billion years, and for most of it, the rings we admire today did not exist at all. They are young, possibly only 100 to 400 million years old, born from the destruction of a moon or comet torn apart by tidal forces. Now Saturn is finishing what it started, consuming the evidence 1 ton at a time. When you look up at the night sky and see Saturn as a steady point of light, you're not looking at a peaceful ornamental planet. You're looking at a world actively destroying its own most famous feature, generating storms that have outlived human civilizations, and squeezing its moons hard enough to either melt them or freeze them, depending on its mood. Saturn isn't beautiful because it's gentle. It's beautiful because nothing about real violence ever announces itself honestly from a distance. I hope this gave you a new perspective on the ringed planet we thought we knew. The solar system is far more violent than it appears, and Saturn is the proof. If you enjoyed this video, consider subscribing, and I'll see you next time.